Hello everyone, my name is Richard Bogdan. I'm a software engineer at Bitrise, and today I will talk about what's new with Android data storage, which is mainly about the scope storage. Just let me share my screen, and here we go. In my talk, I will speak about an overview. What is scope storage? What changes? And I'll give you some examples how to use it. The talk will be beneficial for Android developers who haven't discovered the topic in detail. Some background knowledge is required, like how storage access used to work on Android, or how to work with files and data, or what URIs are. I try to keep the examples as easy as possible, and I used Kotlin as a programming language. Okay, so the first big question, what is scope storage? To simplify it a bit, with scope storage, applications will have a more restricted access to files and media. This was introduced in Android 10, but further restrictions will arrive with Android R. Google gave an excellent overview about the topic at the Google I/O in 2019. I highly recommend you watch it. In my talk, I will try to focus more on the developer side, add some more examples, and share my personal experience of experimenting with its features. The second big question is when? When will this change? The restrictions of scope storage affect every application that will set the target SDK version to 29, and they are on devices with Android 10 and above. And the third big question is why. One of the reasons why scope storage is needed is that a lot of applications on Google Play require the storage permission. According to Google, around half of the apps, but the majority of these applications only use this for simple things like uploading a profile picture. Because the access to files on the device requires permission, Google decided that the storage permission is not required in some cases, which do not hold security issues. So the number of applications that need the storage permission could be reduced. This increases the trust in apps, which is good both for the users and both for the application developers. I will explain which are these changes and cases in the following slides. The second reason is that although some applications use only a very tiny part of the file system, with the storage permission, they have access to the whole, which won't be necessary. If you are familiar with information security, you would immediately shout that restrict access to files which are not necessarily needed for the application to avoid malicious usage. This sounds reasonable, in my opinion. The third reason could be that a lot of applications create files through different parts of the file system, which won't be removed when they are uninstalled. This can be an issue as the space on the storage is limited. Scope storage gives better file attribution, so every file that was created by the given application can be removed with the uninstall. This is a useful improvement, I think. Okay, so the next big question, what is affected? accessing to the items in the media store is affected with the changes of the scope storage. Accessing documents and other type of files are also affected, but accessing the private app storage is not directly affected. Of course, that means that the application preferences and databases like room is not affected. Now let's see the details we were waiting for. So exactly what changes? The list won't be complete, but I think these are the most important ones. The changes of scope storage came in two packages. The first arrived with Android 10. These are, you do not need permissions to write your application's private storage, even if it is on the external files directory, so an SD card. To access the organized media collections, you do not need write external storage to add a new item. You do not need permission to access the items you added to the media storage. And you only need the read external storage permission when you would like to access to the shared files that were contributed by not your application. Well, these changes are good. They make things easier. So where's the issue? All the other type of files need the system picker with the storage access framework. That could be an issue. Another change is that we need explicit user consent to allow to edit or delete files on the shared storage that belong to other applications, so to not our application. This means that we have to handle these cases in our current code, I mean for asking for user consent. So we have to update our code. These do not seem too drastic, but depending on your application size, the type and the number of usage of the storage, it can be a difficult task for your developer team. Luckily, Google knew this and added the attribute named request legacy external storage, which if you set to true, your app will work as before. You have to add this attribute to the Android manifest file. Yeah, and at this point, you might tend to ask, okay, so problem solved, why bother? The reason is that this attribute won't be allowed to be used forever. It's like a life buoy, saves you now, but you have to make an effort in the future. Another change was access media location permission, which is required when you try to access the location metadata of the given image. Okay, and there are several changes with Android R, but the most important ones I would like to highlight is one is the manage external storage permission. With this, you can access to folders that you normally won't be able. So for example, the root, the app data, or the downloads. If you have an application like a file manager that really needs this functionality, this is for you. So, however, it's not only that you just add it to your Android manifest and you are done. You have to ask for it on the Google console, and Google will grant it to your app to make sure it is used only when it's really needed. The other important change with Android R is that you can create batched operations when you need user consent. So for example, previously you had to grant permission one by one when deleting multiple images, but from now you can create batch requests and you can approve or reject once. Now we have the details. Let's look at the problems. So what can be an issue in my current code? If I want to adapt it, how should I do it? And how to update existing projects. Now answering them, what can be an issue in my current code? The first logical guess is deprecations. Write external storage. According to Google, the Google I/O, they said that it will be deprecated in the future. Nothing to worry about because it will take time. Just remove it when it is deprecated. Action media scanner scan file. This is an intent action that was used to share an image in the media store. If you have used this, you should instead now insert it directly to the media store. So you have to update your code if you use this. There is get external storage directory method. The path returned from this method will be no longer accessible to applications. You can migrate your application to alternatives like get external files dir method, or using the media store directly, or the action open document intent. Again, in this case, you have to check your code and update it. The get external storage public directory method is the same with get external storage directory, so I won't repeat myself. Get external media dirs, the directory still exists, but Google recommends using media store directly instead. And with media store images, image columns, latitude and longitude, these will be always null, so you won't be able to query it. And as I mentioned in the what changes section, you have to ask for the access media permission, and instead you have to use the EXIF interface, and there is the method called getLetLong. And one important note I want to highlight, you should move your files, which are only required by your application, to your application's private storage. Otherwise, you may lose access, or you have to ask for user consent. Okay, let's jump to the next big question. How should I use it? I will demonstrate to you in the next few slides how to take photos, save them to the media store, and delete them. Then how to delete multiple images. In this slide, I am showing the current Android example for taking pictures and saving them. In high level, you create a temporary image file in the pictures directory. You get a URI for it and pass it to the take photo intent. You can see how to dispatch the take photo intent on the left side, and how to create a temporary image file on the right. This is fine, but what if we want to save it to the media store to make it available for all applications? This is the additional code which I created for the sample for saving the taken photo to the media store. For the first site, it looks a bit long, so let me give you the high-level perspective. Let's start with the left side. We create a content values object, which can be used by content providers. We set the name and the MIME type of the image that will be stored in the media store. Then we set the relative path of the image in the media store. This is useful because you can organize them in a better way. For example, you can add a subdirectory with your application's name, or something that indicates the type of the pictures. For example, you can name it profile pictures. This feature was added in Android 10. The next is we set the is pending flag to true. This means it won't be available for other applications, only for our application. This can be used to avoid other apps to access it before the data content is copied to it. It's especially useful in cases like downloading an image, because the download could take a lot of time. Again, this is also an Android 10 feature. The next step is we insert it to the media store. Then we get the temporary file and copy its content to it. You can see more details on the right side, but let's continue here. The last step, if you previously set the is pending flag, it is time to update it to false to let other applications it's ready for viewing. Okay, now let's jump to the right side. The first one is a simple method that, depending on your application level, it will set up the file output in the media store. Starting from KitKat, we use the storage access framework. And if your application is below KitKat, we use file paths. The last thing here is to do not forget to ask for write external storage permission if you are below Android 10. So this is how you can use the media store to insert a taken picture to it. Now let's see the next example. The next example is how to read. This was showcased by Google on the Google I/O in 2019. I only added some extra to it, so I do not want to repeat them and go step by step, just to give you the high-level idea. Create queries for the media store and get the data you are interested in. If you need more details or explanation, I highly recommend to check out the linked video. My additional part to the original sample is getting the location of where the media was taken. Things to note: make sure you have the storage permission if you will read other applications' images from the media store. From Android R, get the original image to be sure the EXIF data is present. With the EXIF interface, get the lat-long value, and do not forget previously to ask for the access media location permission if you are running it at least on Android 10. Also keep in mind that these type of queries can be big, so it is highly recommended to not run them on the main thread. And as I said before, media store will show only your application specific items if the read external storage is not granted. Okay, the next example is updating and deleting media files. Again, this is really similar to the sample that was shown at the Google I/O. In a few words, we do the following. We try to modify the given item. If we get an exception and it is a recoverable security exception, we catch it and launch the intent sender to ask for user consent. Of course, this is true for Android 10 and above. This looks easy, but what if, for example, I want to delete multiple images? It will be a bit more difficult, as Android 10 does not offer a solution for batch operations. They only arrived in Android R. Let me show how I experimented with it and what was my conclusion. This looks really similar to the previous slide, but there are small changes. First, we have a set of images and we iterate over them. Then, as before, we just try to delete every image. And if we get a recoverable security exception for one, which means we need user consent to delete it, we just store the URI in a member variable list. At the end, we deleted what we were able, and we have the list which requires user consent. Now it is time to delete those too, but it cannot be done the same way on every Android versions. We have to create a method that will handle this based on the API level. So here is a method on the left side which will handle the differences between the Android versions. Below Android 10, the previous slide covered all part of the code. So as you can see, here we just call it and it's done. It's that easy. On Android R, we create a batch operation and a user will receive a single dialog asking for the consent to delete. All we have to do is to check the activity result. You can see it on the right side. And if we got the consent, we can safely delete the pictures and clear the member variable. The tricky part is on Android 10. As I mentioned, we cannot do batch operations. Here we only add every URI that we want to delete to the member variable named pics to delete. And then we call a method named delete one by one. Let's see on the next slide what it does. On the left side, you can see the method named delete one by one. This will do the trick. We call this method recursively until every item from the list was iterated once. Obviously, the first thing to check in this method is that there are still items we haven't touched yet. If it's not empty, then we grab the first item and try to delete it. Two things can happen. One is that we already have the permission to delete it, so we remove the URI from the list because we handled it and call the method recursively to proceed with the next URI. The other thing that could happen is that we need user consent to delete it. In this case, as on the previous slides, we catch the recoverable security exception and launch an intent for asking the consent. Now, let's look at the right side. When the intent was fired, the user will receive the dialog asking for the consent. And if the user makes the decision and presses one of the buttons, the on-activity result will be called. No matter what the user clicked, we remove the item from the list as we iterated over it. Then we check the result, and if the user granted us the consent to delete, we delete the item, and again, call delete one by one to proceed with the next item. As I said, it will run until every item was iterated over at least once, and not at least, exactly once. And in the end, the user will delete exactly what he or she wanted. Okay, that was mainly I wanted to present to you. Now it's time for questions. I will share you the Slido link just in a moment. Okay. Okay, so the first one is thank you. Thank you for listening to me. So, a second one is, what would you recommend to a user as the lowest Android version to have on their device if using the camera on an application? This is a tricky question because multiple things could play a huge role in this type of question. So I mean, for example, security or newer libraries that are available from higher API levels should be one thing to think of. Also, I always recommend to check the usage distribution between Android API levels. I would say that I usually aim for Android 6, I mean currently, or to Lollipop, but you should not aim below Android KitKat, but that's just my personal opinion. Others may argue with that. Okay, anyone else have questions? Then thanks for joining and have a good day and see you next time. Probably I will share a bit more about how to work with documents because I wasn't able to fit those into my speak. Stay home and stay safe and see you. Bye.